Alright, for number 13, got a word problem here talking about Dunkin' Donuts stores. So Dunkin' Donuts began with 2 stores. And it says after 2.25 years, then there were 14 stores. What it's asking us to do in part A, you want to find the exponential growth function that describes the information here. So if you're going to do a growth or decay type problem, you have to start with the base formula. So we have to make sure we know what that one is. Okay, so here's our growth formula. We have A equals A0 to the KT. We're going to put our initial information in here and we're going to solve for the growth constant, which is something that this problem didn't originally give us. Okay, so it says the A is basically that's the amount after growth. So basically 14 stores we have. Initially we started with 2 stores. We don't know what the growth constant is, but the amount of years we have is 2.25 years. Okay, so that's all the information that's been provided. We want to go through this first to get the K constant, and that's going to be what we'll use when we write our exact growth function for this given information. We're going to first divide by both sides by 2, and we get 7 equals, and I'll write this as 2.25. I'll put the number first there, so 2.25K. We want to clear out the E. To clear out the E, what you want to do is take the natural log of both sides. So we're going to do natural log of both sides over there. And we do that because we want to cancel out the E that's here. Natural log and E, that's both going to cancel out. And we'll get natural log of 7 equals 2.25K. So next thing we're going to do is divide both sides by 2.25, and we get K is equal to natural log of 7 over 2.25. And we want to put this into the calculator. We're going to round to, again on the test, 4 places is sufficient. If you put that in, you get 0.8648 rounded to 4 places. Now that's not it. You don't want to put that down for your answer. What's it asking for? It's saying find the exponential growth function, which means you've got to have some kind of equation that's in there. So a function means that I want to put the function notation in with it. In this case we're using the t, so I want to go ahead and write it this way. So a of t is going to equal, now initially it started out with 2 stores. I have e, here's the k value, 0.8648, and then I'm just going to put a t in that one. So this right here, that's the answer to part A. Okay, so it's this equation, that whole thing is going to be your answer. Now the second part of this question, for part B, it says how many stores are estimated to be in Las Vegas after 3.5 years. Okay, so let's go ahead and do part B. Now we're going to use our answer we got for part A. What this is saying is it says how many stores are there after 3.5. So we're going to put a 3.5 in there for T, which means that you want to put a 3.5 in over here in place of T. Okay, so we want to work this out. Whatever answer we get here, this one says round to the nearest whole number. So again, you got to watch your instructions. Sometimes you want to round to the nearest whole number, otherwise it may tell you to round to another decimal place. Okay, so we're going to multiply the exponent part first. That's 3.0268. And then if we put that number into our calculator, you get about 41 stores. So you got 41.2 or something like that, but it says round to the nearest whole number, and so you're just going to put 41. So here's our 2 answers. The first one, it's got to be a function, so it has to be an equation. So we put this whole equation in there. But part B, we'll go ahead and write that just as a regular number, so our final answer is going to be 41. Now another variation of this, it might tell you how long will it take to reach a certain number of stores. So in this case, you might have some information that you're going to plug in on this side, and you're going to solve for t. In that case, you'd be going through the same algebraic steps as you did here for part A. So it could ask you either one of those. It'll either ask you something like this on this sample, or it could also ask you for how long will it take to reach a certain number of stores. In other words, you're kind of going along solving it kind of that way.